Welcome to another 3 steps to sketch. Today we're going to look at a basic unshifted cosecant graph, y equals 2 cosecant of x over 2. So here's our template and our equation and grid. And looking at our equation, we see it's in that general form, y equals a cosecant bx. There are no shifts here. And so we know we can use this basic template. This is for unshifted cosecant graphs. So we'll start with step 1, find the companion equation and all the essential information. So our companion equation is simply going to be our equation, but we'll replace the cosecant function with its reciprocal function, sine. So it'll be y equals 2 sine of x over 2, or I'm even going to go ahead and write that as 1/2 x, same thing. It's just easier to see b as 1/2. So we're basically going to graph this companion equation, and then in step 3, we'll transition all the points into the cosecant points and the cosecant graph that we actually want. With that being said, if you aren't familiar with how to graph sine equations, now would be a great time to go to the video description and check out the links that I'll post there for graphing sine equations. All right, so let's analyze this sine equation, our companion equation. So to get the base graph, we want to know a, which is the coefficient in front of sine, so 2. That tells us our amplitude is 2, so from midline to maximum or minimum. And that'll be helpful in plotting our companion pattern in the next step. We see b, the coefficient of x, we've already said is 1/2. That tells us we should have half a cycle of our graph between 0 and 2 pi. And it also helps us find the period. We use 2 pi divided by b. So 2 pi divided by 1/2 is going to be 4 pi. So our period, or the length of one horizontal cycle, is 4 pi. So now that we have that information analyzed, we can choose how to label our axes. So we're going to choose some scales here. The horizontal scale is really the most important, in my opinion. I always like to take the period and divide by 4, because this will help all of our key points in the next step align nicely with our horizontal tick marks. So if you take your period and divide by 4, that's 4 pi divided by 4. So we'll count by pi as we label our horizontal axis. For our vertical scale, 1 will usually work really well, as long as your a value isn't crazy. And even then, it might work well. So let's go ahead and take a minute to label our axes. So starting on the horizontal axis, we're counting by pi. So we have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, and then we can go in the negative direction, same values, just negative. We have negative pi, negative 2 pi, negative 3 pi, negative 4 pi, finally caught up there, and negative 5 pi. And then we're counting by 1 for the vertical axis here. All right, and negative. Now we have everything nice and set up for that companion pattern in the next step. Before we move into plotting the companion pattern, I like to go ahead and find the asymptote generating equation. So to do that, we take the inputs of our cosecant function. So we take, in this case, x over 2, and we set it equal to 0 plus pi k, where k is an integer. And we do this because we're basically applying our horizontal transformations that are in our equation to the original asymptotes of cosecant. So take a look, if you aren't sure about this, take a look at the equation y equals cosecant x, and you'll see that the asymptotes happen at 0 plus pi k, and just substitute in different values for k to get different asymptotes. All right, so again, take those inputs, set them equal to 0 plus pi k, and solve for x. So to do that here, we just need to multiply the whole equation by 2. So we'll write the finished equation over here in our asymptotes equation in our template. We have x equals 0 plus 2 pi k. Or you may just see this written as x equals 2 pi k. So as you let k be different integers, you'll get different asymptotes along your final graph. So we should expect one, if you let k equals 0, we should expect one at x equals 0, or an asymptote on the y-axis. K equals 1 gives us an asymptote at 2 pi. K equals negative 1, there should be another asymptote at negative 2 pi. And I like to go ahead and do this at the beginning to be looking ahead to the graph, and it helps serve as a double check for that final graph when you're actually doing the graphing. All right, now we're ready for step 2. We're going to plot our companion pattern. So our sine pattern, our basic unreflected sine pattern, starts on the origin. So x-intercept on the origin, maximum, another x-intercept, minimum, repeat. So let's go ahead. We're going to start with our first x-intercept on the origin. Our maximum will happen at the first horizontal tick mark to the right, and its y-coordinate will be the value of a, so 2. Okay, notice I'm doing this in light blue. You should be doing this lightly. Of course, this is not our final graph. It's just our companion graph. Okay, so x-intercept, maximum, x-intercept at the next horizontal tick mark, minimum at the next horizontal tick mark, and you get the y-coordinate by just taking the opposite value of a. And then you would repeat, starting again with another x-intercept. So this is the graph of y equals 2 sine 1/2 x. Now that we have our companion pattern plotted, we're ready for step 3, where we recip, sketch, and repeat. Basically, we're going to transition our key companion pattern points into their corresponding key cosecant points. So that's what we call kind of recip. Each of the original x-intercepts will turn into a vertical asymptote. So we can see we'll have one here at x equals 0. We have that one here that we predicted at 2 pi when k is 1. And I'll save the one at 4 pi. That's kind of the start of a next cycle. And right now we're just doing one cycle. Okay, we know that maximums from our companion pattern turn into relative or local minimums. So that just means the lowest y-coordinate in that small area. And then we know that minimums from our companion equation turn into local or relative maximums. So same sort of thing, just the largest y value in that small area. And so here we have one cycle of our graph, y equals 2 cosecant x over 2. And now we can repeat for as many cycles as we want. So like we said, we should have another vertical asymptote here at x equals 4 pi. That's what happens when k is 2. And you can see that you would have another relative minimum here. So that curve kind of works like that. Okay, and we can work the pattern in the other direction as well. So here at negative pi, we should have another local maximum curve and a vertical asymptote here at x equals negative 2. That's when k is negative 1. Another curve that has our local minimum. Another vertical asymptote. This is when k is negative 2. And then another curve that has another local maximum. So here we have several cycles of y equals 2 cosecant x over 2 using this 3 steps to sketch method. I'll post some more worked out examples for cosecant basic graphs. So be sure to check those out. The more you practice with this, the easier it gets. So keep practicing, you can do it. In the video description, I'll also post some links to graphing other trig functions, so check those out too if you're interested. Thanks for watching.